Welcome back to 1200 plus PYQ series of CSIR NET examination. This question was asked in NET December 2019. The question says that the Bethe-Weizsäcker formula for the binding energy in mega electron volt of a nucleus of atomic number Z and mass number A is given as B is equals to 15.8 A minus 18.3 a to the power 2 by 3 minus 0.714 z into z minus 1 by a to the power 1 by 3 minus 23.2 multiplied with a minus 2z whole square by a. Okay, then you were asked that the ratio z by a for the most stable isobar of a is equals to 64. Okay, so in the question let us analyze it deeply. So you were given that formula for binding energy, that is Bethe-Weizsäcker formula. Okay, and you were asked what is the ratio of z by a where a is equal to 64 given. Okay, so let us analyze it. Okay, you know that the Bethe-Weizsäcker semi-empirical mass formula, that is binding energy is equals to ABA minus A surface A to the power 2 by 3 minus A coulombic Z into Z minus 1 by A to the power 1 by 3 minus A symmetric A minus 2Z whole square by A. If you will compare all these, then you can get that here your AB is 15.8. Okay, AS is 18.3, that is your AS is 18.3. This is AC is equals to 0.714 and your A symmetric, that is 23.2 is your A symmetric energy term. Okay, if you will compare the given equation with the Bethe-Weizsäcker semi-empirical formula, okay, then you will easily get that this coulombic energy term is equal to 0.714 and asymmetric energy term is equal to 23.2. Okay, now we will find the ratio z by a. Okay, a is given 64. Now we have to find z. So what we will do, we will use this semi-empirical mass formula or the Bethe-Weizsäcker formula to find the z, that is the atomic number for the most stable isobar. Then we will solve it. Okay, so let's check the option. Here you are given with 4 options, that is first option 0.30, second option 0.35, third option 0.45 and fourth option 0.50. So let us now solve it. Okay, now for the most stable isobar, the direct formula is given. In the question we were asked to find z by a. So a is known, unknown is z. We will find z by using this direct formula. Okay, the direct formula for finding z, if you are given with mass number a, for which mass number, okay, let's say mass number a is equals to 64, means for 64 which z is most preferred, which z is most stable, right? So what we will do, we will write the formula, that is z is equal to z naught is equals to a by 2 plus a coulombic by 2a symmetric a to the power 2 by 3, where a is the mass number, AC is the coulombic energy term, and 2a symmetric, that is here AA symmetric, AA is the asymmetric energy term. Now in the question you will compare, okay, with the Bethe-Weizsäcker semi-empirical formula or the Bethe-Weizsäcker formula, that is this is okay, that is binding energy is equal to ABA minus A surface A to the power 2 by 3 minus A coulombic Z into Z minus 1 by A to the power 1 by 3 minus A symmetric A minus 2Z whole square by A plus or minus A pairing by A to the power 3 by 4. Okay, we actually don't need it because in the formula this term is absent. So okay, this is the formula, right? The general formula for the Bethe-Weizsäcker. Okay, now we will compare this formula with the given equation. Okay, in the given equation, if you will compare as told earlier, this is the given equation in the question, and this is the general formula, that is the Bethe-Weizsäcker formula. You will compare all these terms, right? You will compare all these terms, then you will get that the Coulombic energy term is equal to 0.714 and asymmetric energy term is equals to 23.2. So what you will do now, you will simply put AC value here, asymmetric value here, and your this A is 64. Okay, now let us solve it. So on putting all these values in this formula, we are getting that this Z is equal to Z naught, which is equal to A by 2 plus A Coulombic by 2 asymmetric. That is A is equal to 64 by 2 plus A Coulombic, 0.714 by 2 asymmetric. That is 2 times 23.2. Okay, 2 times 23.2, because here asymmetric is 23.2. Then A to the power 2 by 3, and 64 to the power 2 by 3. Hence you got that your Z is equals to Z naught is equals to 64 by 2 plus 0.714 by 2 times 23.2 multiplied with 64 power 2 by 3. You will solve this value by using calculator, then you will get that this is coming to be 0.015. Okay, hence you got that this Z is equals to Z naught is equals to 64 divided by 2 plus 0.015. On solving this, we are getting 0.015 and 64 to the power 2 by 3 as it is. Okay, now what you will do, you will put all this value in your scientific calculator. In your CSIR NET examination, there is a virtual calculator on your screen, so you can use that to calculate easily and very quickly. Okay, so if I will calculate that, then I am getting 0.246, means 0.015 multiplied with 64 to the power 2 by 3 comes out to be 0.246. Okay, hence I am getting that Z is equals to Z naught is equals to 64 by 2.246. I simply just add it, that is 2 plus 0.246. Okay, it is coming to be 2.246. so that is Z is equals to Z naught, which is equals to 64 by 2.246. If I will calculate it, then it is coming to be 28.49. Okay, so for the most stable isobar, okay, for the most stable isobar, A is equal to 64. I am getting that my atomic number is 28.49. If I round up it, let's say it's 28. Okay, it's 28. Okay, or 28, 29. So our Z is 28.49. So we can round out it as per the requirement of the question, that is 28 or 29. But in our question, we were told to find Z by E ratio, right? Z by E ratio. So here A is equals to 64. It is already known. And now by using the direct formula for Z equal to Z naught, we have got that the Z value is equals to 28.49, right? So now what we will do, we will simply just divide, that is Z by A, which is equal to 28.49 by A, that is 28.49 by 64, which comes out to be 0.445, which is nearly equal to 0.45, right? Okay, which is nearly equal to 0.45. so if we check the options, let's see, is there any option right like that? Okay, so 0.30, 0.35. okay, here C. So C is the correct option. Okay, because we have found that this Z by A ratio comes to be 0.445, nearly equal to 0.45. so here C is our correct option. Okay, now you can easily remember this formula for the most stable isobar and simply put the value directly here, then it will save you a lot much of time. But this formula can also be derived by using this, that is dBE by dz is equal to 0. If you will differentiate this formula, and then finally you will get this. Okay, this is a derivation, there is a long derivation of nearly 1 page, but it will just waste your time in your CSIR NET examination. So better just remember this formula that is z equal to z naught is equals to a by 2 plus a coulombic by 2 asymmetric a to the power 2 by 3, where a is the mass number, ac is a coulombic energy term, and a symmetric is a asymmetric energy term. Okay, now if you are getting helpful from this PYQ series, then please check this playlist and subscribe my channel Researcher on Physics. Thank you. Have a nice day.